Hello, this is Daniele Inaudi. I will be hosting this webinar today on 20 years of structural health monitoring. You should hear my voice through your PC, speaker or headset, or through your telephone if you dialed in. This seminar will take about 20 minutes, and during the webinar you can ask questions using the questions panel that you find on the right-hand side of your screen. You can type in your question and I will answer them at the end of the presentation or later on by email. Today's presentation is about the history of SMARTEC. This year we have turned 20 years old, so it's a good time to reflect back at the history of the company and at the same time see how our field of structural health monitoring has evolved over those years. First, a little history about our company and the technology that we have developed. Everything started in 1992 from a project at the Swiss Federal Institute of Technology under the direction of Professor Pflug. And in that project, we started developing the SOFO sensing technology, our long-gauge fiber optic sensors. This was a multidisciplinary project involving both civil engineers and optical engineers. So it was the ideal environment to develop a new technology, but at the same time also to make sure that that technology would be useful for practical application and easy to use and implement in real world. It was, we were lucky to have access to a number of concrete structures, in particular bridges that were built close to the campus, and so we could test those sensors relatively quickly in the field, and the project developed quite quickly. Following that success, it was decided that the technology was useful for commercial application, and so from the project at EPFL, SMARTEC was founded in 1996, 20 years ago. So SMARTEC developed the technology further and commercialized it for about 10 years. And later, SMARTEC was acquired by Rocktest in 2006. Rocktest was already active in the production and commercialization of both conventional and fiber optic technologies, complementary to SMARTEC. So it was a very good matching between SMARTEC and Rocktest. Later in 2010, Rocktest became part of Novametrics, a very large concern that covers and owns a number of companies active in structural health monitoring, sensors, and similar applications. So as mentioned, in 2016, SMARTEC is turning 20 years old. And during these 20 years, we have deployed a large number of applications, including more than 1,000 projects, 15,000 sensors, and 300 systems deployed worldwide. SMARTEC is now part of Novametrics, a major player in sensing and instrumentation, and you probably recognize several of the brands on this picture. It includes producers of vibrating wire, fiber optic, MEMS, and other sensors based on the most diverse technologies. So within this group, we are now able to offer solutions that are ideal for any application by selecting the appropriate solution or combination of technologies for any given project. Reflecting back about the main company development phases, I have found 3 major steps. Initially, we were focused mostly on developing the SOFO technology, so product development, sensor development, readout unit, software, etc. And this was really the early phase of the company where we were focused on a single product or product line. Just a few years later, 3-4 years later, we realized that although SOFO is a very good technology, it could not be used for all the applications. So we started looking at other complementary technologies, always focusing on fiber optic and other novel sensing technologies. In particular, we introduced product based on distributed brilliance sensing, our DITEST product line, fiber Bragg rating, our MUST product line, distributed Raman sensing, our DITEM product line, as well as other hybrid solutions mixing fiber optic and other technologies through software integration. Even later, we went into a phase of application diversification. So initially, we were focusing a lot on structures, in particular concrete structures, but then we moved also to other civil and geotechnical applications, such as tunnels, dams, dikes, etc., and into the oil and gas industry with pipeline monitoring. At that time, we also were part of the Rocktes group, and so we had access to traditional sensor. So the strategy was to develop a complete toolbox of solution where we could mix fiber optic and traditional sensing in application that might benefit from that combination. So SMARTEC today is a major supplier and system integrator of all mainstream fiber optic sensing technologies. So we have become kind of agnostic on the fiber optic technology, but we aim to offer the best solution for any specific application. And in terms of fiber optic, we are covering products based on fiber bra grading, Brillouin, Raman scattering, Fabry-Perot, and the SOFO technology. Our product range includes everything from sensors to measure deformation, strain, pressure, water levels, displacements, tilt, etc. Readout units for point and distributed sensors, and software to acquire, manage, display, alert, and in general make the best possible use of the data resulting from the measurements. Our area of application include bridges, buildings and tunnels, as well as dams and geotechnical. So these were the original civil engineering application. More recently, we have done more and more application in pipeline monitoring for leak detection, strain monitoring, etc., chemical industry, cryogenic application, nuclear, and naval. Now I would like to go back through the history of the company from a project point of view. So I have selected a few projects that were important for our history in terms of achieving new goals or new results or introducing new technologies. And so in the next few minutes, I would like to cover those applications in more detail and at the same time go back in time and see how the field of structural health monitoring has evolved in parallel with the evolution of our company. The first very important project for us was in 1996 with the Versoix Bridge in Switzerland. It was the first large-scale application of fiber optic sensing to bridge monitoring, not only for us but worldwide. And in this bridge that was being enlarged and refurbished, we installed more than 100 SOFO sensors to allow a 3D deformation measurement during refurbishing and during the load test of the bridge. So this was a challenge both in terms of production because we had to produce more than 100 sensors in reproducible quality, install them, and almost all the sensors worked and the project was a success. So it was a very good beginning for SMARTEC and the SOFO technology. In 1999, we worked on this interesting project with UCLA and Clatrans in Los Angeles. It was the first large-scale application of fiber optic sensing technology in the US. The pile was instrumented with chains of SOFO sensor to monitor cracks above and below ground. It was a very interesting research project and it allowed us to showcase our technology also in North America. Another important step came in 1999 with the Reale Monza project. In this case, for the first time, we installed a permanent and remote monitoring system based on SOFO technology. The previous project, in most cases, the sensors were installed permanently, but then an operator would go on site and take readings from time to time. But in this structure, we installed the sensor, but also the readout unit that would take reading permanently, transmit the data remotely, and set off alerts if predefined thresholds were exceeded. It was also one of the first application to historical structure, and we learned how to use the SOFO sensor on timber and masonry structure by surface installation. Another milestone project in 2000 was the San Giorgio Pier in Genova, Italy. This was also a permanent monitoring system, and as an evolution of what we've seen in the project in Reale, in this case the environmental conditions were much more difficult. This is a pier used to unload coal, so there's a lot of dust, and the environment was really difficult, and fiber optic sensor, being explosion proof, were also the ideal solution for this particular application. It was also a case where the system really needed to be reliable and work for many months, because it was to follow the evolution of the dredging works that were performed to increase the water depth of this particular pier. In 2001, we started working on the Alp Transit Tunnel project in Switzerland. The tunnel has recently been opened to the traffic after many years of construction, and is now the world's longest tunnel. In this case, we applied the SOFO sensor to the monitoring of concrete, both at the portals and on the liner, to evaluate the deformation due to the rock pressure. So it was a very interesting project for us, and also one of the first applications to tunnel monitoring of SOFO technology. 2001 also marked the beginning of another successful application of fiber optic sensing, the monitoring of buildings in Singapore. This has now become the largest structural health monitoring project worldwide, with more than 10,000 sensors installed. In 2001, the Housing Development Board of Singapore decided to install 10 SOFO sensors in each building they would build, to allow quality control and the verification of the structural health after events like tremors or earthquakes or typhoons, etc. And some of those buildings have now been monitored for 15 years, not continuously but periodically. In the picture here was one showcase project in Singapore, the Duxton complex. In this case, we also installed a permanent monitoring system that was addressing the monitoring of the buildings themselves, but also of the bridges that connect the different buildings together. So it's a rare project where we monitored a building and a bridge at the same time. In 2003, we had one of the first applications of distributed strain sensing at the SNAM ReteGas pipeline monitoring project in Italy. This pipeline is installed in a landslide area and is therefore subject to strain induced to the pipeline from the earth movement, and the owner wanted to understand how that strain would be distributed along the length of the pipe. So a distributed fiber optic sensor was installed on the pipe and then monitored on a regular basis. So it was for us one of the first field applications of distributed strain sensing, and one of the first applications to pipeline monitoring. In 2005, we started working on another milestone project for SMARTEC. The Göta bridge in Sweden is still the largest application of distributed strain monitoring for structural monitoring in the world. In this case, we are monitoring almost 5 kilometers of girders to identify cracks that can appear due to fatigue to this aging bridge. And this system is still in operation today, measured on a regular basis to make sure that no new crack appear on this bridge. So this project was a challenge in terms of installing the sensor on an existing bridge over a river, but at the same time also make sure that all the data management and processing would allow the use of the system as a security system to guarantee the safety of the bridge. 2006 was the date of this project in Halifax, Canada. In this case, we used structural health monitoring to extend the lifetime of an existing structure. So on this ice hockey arena that is also used for concerts, the owner was afraid of the combination of load produced by snow and concerts, for example, with equipment hanging from the roof itself. There was a need to maybe retrofit this roof based on new regulations that were enforced in Canada, but at the same time the engineer believed that there was some residual load-bearing capacity built into the roof itself. So by installing a network of fiber Bragg rating sensor and laser distance meter, we recorded strains and deformations during snowfalls and concerts, and the engineer was able to demonstrate that the roof was perfectly safe and no refurbishment was needed. So it's a nice example where structural monitoring really helped immediately save some money to the arena owner. 2008, following the tragic collapse of the I-35 West Bridge in Minneapolis, we were involved in the instrumentation of the new bridge. In this case, we combined SOFO and vibrating wire traditional sensor as well as corrosion sensor to monitor the new concrete bridge that was built in record time to replace the one that had fallen. The main purpose of the project was, of course, to reassure the public about the bridge safety, but it was an interesting case where structural monitoring was really part of the proposal and was included in the fast construction plan. So it was challenging, but at the same time very rewarding to contribute to this very visible project in the United States. 2010 marked one of the first application of our distributed temperature sensing technology to ammonia leak detection, in particular for this plant in France. Yara was looking at new technology to localize and identify small leaks of ammonia, and in the meantime this technology has been applied to many other ammonia plants and has been certified as a safety barrier with a SEAL certification. We now have more than 10 systems deployed based on that principle, and so ammonia and liquefied natural gas leaks have proven to be a very good match for distributed temperature sensing based on fiber optics. 2001 was also an interesting year for this particular application, where together with our partner the Polonia, we instrumented the VEGA launch pad in French Guiana. So that's an ESA facility to assemble and then launch the VEGA rockets, and the monitoring system does not concentrate on the rocket itself but on the structures like this big hangar that is used to assemble the rocket itself. So we were measuring strain, vibration and temperatures during launch, and so it was kind of a different application of our technology. Finally, in the last few years, we had another challenge to develop and produce sensor for the ITER fusion reactor in France. ITER will be the largest fusion reactor in the world, and its technology is based on using cryogenically cooled superconducting coils, and these huge coils need structural health monitoring. So we need to measure strains, deformation and temperatures, but that structure operates at very low temperature, at minus 270 degrees C. So the fiber optic sensing technology needed to be adapted to work at these extreme temperatures and at the same time operate also in vacuum and in the presence of high radiation. So over the last few years we have first qualified and then supplied sensors, almost 800 sensors based on Fabry-Perot and fiber Bragg rating technology to monitor this very challenging application. So it's another example where fiber optic sensing can fit in a niche where conventional sensors are not suitable. So this brings me to the conclusion of my presentation. The occasion of the 20-year anniversary of SMARTEC is good to reflect back on the evolution of our company, but also on the evolution of structural health monitoring itself. And I think there's been two main phases in these 20 years. The first 10 years, we concentrated a lot on technology development and new sensing systems. And that was not only SMARTEC, but many other companies were also focusing heavily on developing new sensing tools and new sensing technology. In particular, that was the golden age of developing a lot of fiber optic point and distributed sensors, but also other technologies including GPS, MEMS, and wireless transmission systems. In the last decade, from 96 to 2016, the focus has shifted more towards application, development, and commercialization. So using the existing technologies, we have made it more user-friendly through software integration, through combination of traditional and fiber optic sensor, improving the packaging for making the use of fiber optic sensor easier in the field, through standardization and certification, and this has allowed this technology, structural monitoring and fiber optic sensor, to become mainstream and being used not only for research but also as safety system and to answer real engineering questions. And with this, I'd like to conclude this presentation. And again, if you have any question, please use the question panel and I'll be happy to answer those. Thank you.